Hey class, welcome back to Chapter 9, Probability. Today we will be looking at Exercise 9b, Experimental Probability and Relative Frequency. So experimental probability is a little bit different than theoretical probability from our previous exercise in that it's calculated using the results of an actual experiment, okay? We usually write it as a decimal, and the probability of the event, which in this case we call, is just denoted success, okay? So successfully having that event occur is the number of successful trials over the total number of trials. So if I flip a coin 10 times and I flip 6 heads, okay, theoretically, I should get heads 50% of the time, but I actually got it 60% of the time, or 6 out of 10. So 6 out of 10, or 0.6 as our probability, okay? To then calculate the expected number of successful outcomes, so capital E of X, the expected number of successful outcomes, which we call X, we multiply the theoretical probability by the number of trials. So let's give an example a go. We're going to find the expected number of each of the following events. Okay, so here we're looking for the expected number of sixes if we roll a standard dice 6 times. So what's the expected number of times we'll roll a 6 if we roll a dice 30 times? So the probability of rolling a 6, the probability of a 6 is 1 over 6. And if we roll the dice 30 times, okay, then our n is 30, and 1/6 of 30 is 5. So if I was to roll a dice 30 times, or a standard die 30 times, I would expect to roll a 6 on 5 of those 30 occasions, okay? I may roll 1 6, I may roll 20 sixes, okay? So experimentally, our results might be different, but our expected number and therefore our relative frequency from that expected probability would be 5 rolls of the 6. Okay, how about the expected numbers of 1s or 2s? Okay, so here we would have a 2 in 6 chance or a 1 in 3 chance of rolling a 1 or a 2 on a standard dice. And we're rolling it 50 times. So again, our number of trials is 50. And 1/3 of 50, we would expect to roll 16.7 or 17 times, okay? So we would round that up. You can't have a 0.7 of a roll, okay? So we would expect around 17 of those 50 rolls to be a 1 or a 2. And finally, we're going to calculate the expected number of rolling a number less than 4. So we're looking at rolling a 1, 2, or 3. Okay, now that's 3 out of 6, or 1/2 of the possible outcomes. Okay, and we've got 120 as our number of trials, so 1/2 of 120 is 60. So I would expect to roll a 1, 2, or a 3 on 60 of those 120 occasions. Finally, just a quick note, as the number of trials increases, the experimental probability will tend to match the theoretical probability, okay? So what would happen if I took a dice and I rolled the dice 30 times, okay? I might roll 5, I might roll more than that, I might roll less than that. If I roll a dice 100 times, I will get closer to rolling 1/6 of those outcomes as a 6. Okay, if I rolled a dice 1,000 times, I would get closer and closer to that exact 1/6 probability. All right, so the more trials, the more that the experimental probability, or the more likely the experimental probability is to match or equal the theoretical probability. That concludes today's lesson, guys. As always, if you have any questions, let me know, but otherwise, good luck with the work, and I will speak to you all very soon.